Hello and welcome to Golden Geography. Today we're going to think a little bit about human activity in a glaciated environment, and we'll be looking at the Grande Dixence in Switzerland. It's a dam and it has been built for some very specific purposes. Here's the specification part. We need a case study of one glaciated landscape that's being used by people to illustrate the human activity taking place and the reasons for it taking place, the impacts on the processes and flows of material and energy through that system, the effects that has on changing the glacial landforms, and the consequences that has on the landscape, such as changing the valley floor. So we'll start by looking at the reasons why this is taking place, the human activity that's taking place in this very challenging glaciated environment. So the Grande Dixence, it's a dam. It was built for several purposes, predominantly the generation of hydroelectric power, HEP, a green energy to provide electricity for the people who live down valley of this, so to provide electricity predominantly to homes for people who live in Switzerland, but also to control flooding, particularly seasonal meltwater that might generate flooding as a result of particularly spring and summer temperature changes, climatic changes that trigger meltwater and into this particular U-shaped valley. The dam itself is a gravity dam, and it's at the head of the Val de Dixience, and it's a very tall, it's one of the tallest dams we have in Europe, and because of its topography and its position and the meltwater it receives, it does produce a lot of hydroelectric power, as we can see here, enough to power 400,000 homes. So very key for the energy security of Switzerland. So what does that mean for the processes of flows of this environment? What's changed as a result of this human activity? Well, if we think a little bit about the inputs, they're not going to change significantly because they are upstream of the dam itself. So the amount of thermal energy, the amount of precipitation, particularly snowfall, or even debris that's entering the system is not going to change from naturally what we would find there if the dam was not present. So the inputs not really changing, but the flows and the stores are. So if we're thinking about the flows into the dam will be as they would normally be. Predominantly we're thinking about meltwater here coming into the dam here. That would be normal in terms of the amount, but post the dam, beyond the dam, that would be severely reduced because the meltwater is being held in the reservoir behind the dam. The dam itself also prevents the movement of material. There's a lot of sedimentation that takes place, a build-up of sediment that's deposited behind the dam that is changing the flow of sediment downstream and beyond to Lake Geneva. And we have changes in the flows of the water. The water itself will eventually pass through the dam, but it is retained behind it for a long period of time, and there are some changes that occur that we'll discuss a little bit later on. In terms of stores, naturally there would not be a store. The meltwater would just flow as a river would flow down the valley. But because we have the dam, now we have a store here, store of the meltwater that naturally would not occur. So this production of a store is new and different. We also have a change to the outputs. We've got a change in the energy and the type of water that leaves the dam, and that will have an impact on the landscape, and it produces something called scouring downstream of the dam itself. So we do have changes in the flows of the water and the material and energy because of the dam and what that's doing to the natural environment. So here we have an image on the right that shows us the dam from above. It's quite a unique construction, and there's actually been two different stages to the construction, but we can see there's a large area of water behind it, and we can see the changes in the topography leading downstream from it. So the reservoir behind is called Grande Dixence. It's the reservoir. It's significantly large. It's at a very high altitude as well. It receives water coming down from 4 different regions, and it can contain 400 million cubic kilometers of water. So it's a lot of water in this area, which means it has the potential to generate a lot of electricity, but it also has the potential to pose some hazards. So if you were to experience any kind of significant damage to the dam, whether that be caused by earthquakes or any other reasons why, aging, breakdown of materials over time, there is a lot of water behind this dam that's being stored that could potentially cause problems. Sedimentation is taking part in and behind the dam. It has effectively 35 different drainage basins that come down from different parts of the Alps into this area, which means it is receiving a lot of meltwater, and that meltwater is carrying a lot of sediment with it. That sedimentation can and does build up within the lake itself. They have attempted to manage this by putting sediment traps in place, but those sediment traps obviously trap the sediment and the sediment builds up behind them, so they have to be purged or emptied regularly. They call it purging because they're kind of flushing the sediment out, but trying to remove it so it doesn't stay or impact the reservoir. But we do have the deposition of materials here, and that is preventing that material from progressing on further down the valley. The building of the dam itself also changed the landscape. You can see here the pictures of some of that construction taking place. But because of the challenges of that landscape, the topography, the altitude, it meant that the construction took a long time. It took over 10 years. It could only be built during the summer periods. And because of those challenges, they wanted to make it as easy as possible to build. So they used materials within the landscape, which meant they used moraine, ancient moraine that had been deposited, was now being used as material for construction, which on one hand is useful. That moraine may have been situated behind what is now the dam and therefore would have been flooded anyway, and that moraine feature lost, but it does also mean that that feature is lost. So there are definitely some advantages and disadvantages to using the moraine to build the dam itself. So what has it done to the landscape and landforms? Well, clearly that moraine has gone in places to help build this, but it's also helped change the landscape beyond. So what we have here is we have a couple of pictures looking at the landscape beyond the dam, down beneath it, and obviously there is a much gentler slope. It is quite steep still in places, but much gentler, and parts of it have been developed for road systems, etc. But effectively what we are finding is that the water, once that water has passed through the dam, it has increased energy. Behind the dam it has a lot of potential energy, and it also leaves a lot of its sediment behind, which again increases its energy. So the water has a lot more energy, which means downstream, instead of just flowing through the glaciated valley, which is U-shaped, actually that river, as it flows down the valley, meanders down the valley, well, it will erode, and it will erode a V-shape. All rivers erode V-shape. So we're finding that that increased energy that the river had is now being used for erosion, and particularly scouring the base of the U-shaped valley and overlaying it with a V-shaped valley. So we've got channel scour down the river, which is changing the landscape. Not significantly, as you can see here, the river channel itself is not particularly wide, but it is changing and producing a bit of a V shape. The river channel itself is now being heavily controlled, so there is less flooding. There is a much narrower river as well because there is less volume of water and there is less sediment being carried by the river as well. So Lake Geneva, where the river runs into, is receiving less sediment and less water because of the dam. However, as I mentioned earlier, if anything were to happen to the dam, then actually there's a huge amount of water there and it could cause very dangerous levels of flooding if that dam were to burst for whatever reason. And even if the dam doesn't burst, if the reservoir is at capacity and there is very heavy rainfall or storm events, then the way that dams work are, if they know there's going to be a lot of water coming in very suddenly because of heavy rainfall, then they're going to have to open up those gates and enable a lot of water to travel downstream. So it may not be huge amounts of flooding, but you may find this area is flooded, but under controlled conditions because of potentially larger volumes of water coming in and the reservoir being at capacity already. There is the potential of that. Quiz time. Okay, have a little think, pause the video, see if you can answer these questions. Okay, here are the answers. If you got any wrong, just go back and have a little think again. You can always watch parts of the video over. And then last but not least, an essay here. You can use the case study in other ways, so you might find it crop up in shorter answer questions, synoptic questions, etc. But here we have a 16-mark essay looking at human activity. So in a glaciated landscape, we are looking at here, we've got the dam. Is that more important in changing the landscape than physical factors like climate or topography or geology? So you would have one paragraph on human activity, one on physical factors, discussing how they impact our glaciated landscapes. Thank you for listening.